Welcome to qnawire.
Okay, so the question is, what is the canonical shape of a molecule that has 3 bonds and no lone pairs? So actually, this is a classic example given, which is boron with 3 bonds to hydrogen. So I'm going to use this as the example, but this will apply to any molecule for which we have a central atom that has 3 bonds and no lone pairs. So what is the shape? Well, recall that what we're interested in is the number of electron regions, right? And then the number of lone pairs, right? Because lone pairs have a tendency of bending electron regions and changing what we're going to get, right? So if we look at electron regions, we get the electronic geometry, and if we then consider the number of lone pairs, we can get the molecular geometry. So the classic example might be water, which has 4 electron regions because it has 2 bonds and 2 lone pairs. But when we consider that there's 2 lone pairs, we know that those push down on the bonds, and instead of getting a tetrahedral geometry, we get bent. Okay, so just, in this case, we have no lone pairs, right? So we're basically just looking at electron regions. There's 0 lone pairs to change it after the fact. So whenever we have 3 electron regions and 0 lone pairs, we get trigonal planar geometry.